All right, here are our two select practice problems. I'm going to go over problems 2 and 5 from the homework. Okay, so ignore this. This just tells you what number the problem is, right? So this is where the problem actually starts, is there. Okay, so we're going to start with number 2 by building our fence, right? And so first thing we're going to do is we want to isolate the radical, part with the radical by itself. So we're going to get rid of this 6, and the 6 is being added to this, right? It's being added to this positive square root of 3y plus 1. So we are going to do the opposite of that and subtract 6. So that's our first step. Simplify this, you get 5 over here, and then these cancel, and you have the square root of 3y plus 1. All right, next step, and I like to copy this down so you can see the steps really clearly, right? You don't have to when you're working on these, but it's not a bad idea because then you can go back easily. Next step is, because this is now isolated and there's nothing in front of it or being added to it or under it or anything, right, is you just square it. Square it to get rid of it. 5 squared is 5 times 5, so that's 25. And then this, when you square this, it just blitzes, you know, the sign and the 2 and everything, gets rid of all that, and you just get 3y plus 1. All right, now we have 2 more steps before we're finished with this, right? So what we'll do is we'll subtract 1 from both sides, okay? So we get 24. And now we have 3y, and in order to get y by itself, we have to divide. So, you know, a few steps on this, right? But that's how these go, right? So you get y equals 8, and now we will do what a much considerably quicker process, which is just plugging this back in to see if we have an extraneous solution, right? So we have 6 plus square root of 3 times my solution, which is 8, right, plus 1, all under the radical sign, equals 11. So is this a true statement, right? Is this side equal to this side? That's what we want to find. So we have 6 plus the square root of, well, let's figure this out. So 3 plus 8 is 24, and then 24 plus 1 is 25, right? So 6 plus the square root of 25 equal to 11, and probably doing this in your head now and saying, yeah, it does, because the square root of 25 is 5, right? 11, and then 6 plus 5 equals 11. So you do your check step, and you know, it works out kind of nicely, and we like that, right? So this is in fact a solution of this problem. So on to the next one. Now that we have done that, right? So we will go like this, and then we'll move this over here because we'll use that space later. All right, so bring this thing down, right? We're going to probably have kind of something similar in length to this, right? So again, adding 2, right? So we're going to subtract 2. So that's our first step. And you get 4 over here. And then you get negative square root of 3p plus 7. Now, when you have a negative sign in front of your radical, the easiest way to get rid of it is to either multiply both sides by -1 or divide both sides by -1. I'm going to use divide because I want you to think of a negative sign in front of anything. It's the same thing as -1, right? So whenever you see a negative in front of a parentheses, think of it as -1 in front of the parentheses, all right? So it's the same thing, right? And then it becomes kind of pretty clear that, oh, well, to get rid of anything in front of it, you just divide by it. So it's -1, and you divide this side by -1. And so then you're going to get the square root of 3p plus 7 equals -4. So it just basically changes the sign, right? I'm going to copy this down because my next step is going to be my squaring step. All right, so copied it down. We'll square both sides to get rid of the radical, right? So my radical goes away. You get 3p plus 7 equals -4 times -4 is positive 16, right? So that's what we put right there. And now we will subtract 7 because now we still got a little bit of solving to do because we got to get to p. So do the adding, subtracting first. Get 9, and then you get 3p equals 9. Let's divide both sides by 3, and you get P is equal to 3. Okay, so here's our solution. We are going to, I'm not going to box it yet until I verify it, right? So we're going to, just to be safe, we are going to put it into our check steps, right? So we're going to go 2. I always hate that it does that. 2 minus the square root of 3 times my p is 3, right? So substitute that in, plus 7, all under the same radical, equals 6, right? So we have 2 minus the square root of, well, this gives me 9, right? And then 9 plus 7 is 16. All right, so equals 6. So that's going to work out nicely. So we got 2 minus square root of 16 is 4, equals 6. And 2 minus 4 is negative 2, right? The negative is bigger, so your answer is going to be negative. And negative 2 equals 6 is what we wind up with, which, as hopefully you will recognize, is false. This is a false statement. So when you get a false statement, that means that there is no solution because this was an extraneous solution. And hopefully you're starting to recognize now that even though you're going to need to show the work still, hopefully you're recognizing that when you have a negative in front of your radical, generally speaking, that's when you're going to have an extraneous solution, unless the other side is negative. Right, but as soon as this kind of becomes negative over here and this is positive, then you've got a situation where it's not going to work out no matter what you do. All right, so there are your two walked through examples from the practice. Go forth and have fun. Hey.